Hello and welcome. Today we're diving into a question that is absolutely critical for anyone using AI in their business. How do you really know if your model is doing its job? Because as you're about to see, the most common answer, well, it can be seriously misleading. Let's get into it.
Okay, so just imagine this for a second. Your data science team comes to you and they are just beaming. They've built a brand new model to detect fraud. And get this, it's 99% accurate. Wow, that sounds incredible, right? Like you've totally nailed it. But is that the whole story?
And this is where it gets tricky. That beautiful 99% accuracy score, it could actually be hiding a huge flaw. Think about it. If only, say, 1% of all your transactions are actually fraudulent, a model could just play it safe and predict not fraud every single time. And technically, it would be 99% accurate while doing absolutely nothing to catch the very thing it was built for. So, to really see what's going on, we have to look under the hood.
And the first tool we're going to use is called the confusion matrix. Now I know, the name sounds a little intimidating, but don't let it fool you. It's best to think of this as a simple but really powerful scorecard for your AI. It doesn't just tell us if the model got something right, it tells us how it was right and, probably more important, how it was wrong.
You see, every single prediction your model makes has to fall into one of these four boxes. A true positive, that's a home run. It correctly flagged fraud, that was really fraud. A true negative is also great, a correct rejection. But these other two boxes, that's where the trouble is. A false positive is a false alarm, flagging a totally legitimate transaction. And a false negative, that's a total miss. That's actual fraud slipping right past you.
Let's use a spam filter to make this super clear. Let's say we have 100 emails. Our model correctly flagged 50 of them as spam. Those are our true positives. It also correctly identified 35 emails that were not spam and left them in our inbox, our true negatives. But here's the important part, the errors. It completely missed 10 spam emails, and even worse, it sent 5 perfectly good emails to the junk folder.
And all of this brings us right back to that first metric we talked about, accuracy. It's the one everybody knows and loves because it's so simple. It just asks a basic question. Out of all the predictions, what percentage did we get right?
So, for our spam filter, we just add up the correct predictions, the 50 we caught and the 35 we correctly ignored, and divide by the total. That gives us 85% accuracy. And just like that 99% number from before, 85% sounds pretty darn good. But it tells us absolutely nothing about the frustration of those 5 important emails we lost or the risk of those 10 spam emails we missed.
And this, right here, is the real heart of the issue. When you're evaluating an AI model, it almost always comes down to a balancing act between two competing ideas, precision and recall. And honestly, understanding this trade-off is probably the most important thing you can do to make sure you choose the right AI for your business.
All right, first up, let's talk about precision. I want you to think of precision as the quality metric. It answers a very specific, very important question. When my model points to something and says, "That's it," how often is it actually right? So to figure that out, we take our true positives, those 50 spam emails we correctly caught, and we divide them by the total number of emails our model claimed were spam. That includes the 5 false alarms. And that gives us 91%. What that means is when our model says, hey, this is spam, you can be 91% sure it's right. That's a very trustworthy signal.
So when is this what you want to focus on? Well, it's when the cost of a false alarm is super high. With a spam filter, you just can't risk an important email from a client or potential job offer getting lost in your junk folder. Your main goal here is to avoid those false positives, even if it means you have to be a little extra cautious and maybe let a few more actual spam emails sneak into your inbox.
Okay, so the other side of this coin is recall. If precision is all about quality, then recall is about quantity. It's about being comprehensive. It asks, of all the spam emails that were actually out there, how many of them did we manage to find and catch?
In our example, there were a total of 60 spam emails sent. Our model caught 50 of them. So we take our 50 true positives and we divide that by the total number of actual spam emails out there, which is the 50 we caught plus the 10 we missed. That gives us a recall of 83%. So we found 83% of all the spam.
And the business case for recall can be life or death. Think about medical diagnoses or credit card fraud. In those cases, the absolute worst thing that can happen is a false negative, missing a real disease, or letting a huge fraudulent charge go through. For these problems, you'd much rather have a model that casts a really wide net and maybe creates a few false alarms than a model that misses even a single critical case.
So, this brings us to the really crucial point. There is a fundamental trade-off here.
If you aim for super high precision, you're going to have fewer false alarms, but you run the risk of being too cautious and missing some real cases. If you go for high recall, you'll catch almost everything, but you're probably going to get a lot more false alarms. The thing is, you can't have both cranked up to 100% at the same time. Improving one usually means the other takes a bit of a hit.
So if you can't have it all, what do you do? How do you measure what the right balance is for you? Well, thankfully, data scientists have come up with some clever metrics that help us do just that. Let's take a look at two of the most popular ones. So first up is something called the F1 score, and it's pretty brilliant, actually. It combines both precision and recall into one single number. It uses a special kind of average that heavily penalizes a model if one of the scores is really low, even if the other is high. So to get a good F1 score, you have to be good at both precision and recall. It forces a balance. For our spam filter example, the F1 score comes out to 0.87. This one number gives us a much more complete, more balanced picture of how our model is doing than just looking at accuracy or precision or recall all by themselves. It's a fantastic metric to use when both false alarms and missed cases are things you want to avoid.
Now for a really cool one, AUC-ROC. This is a measure of how good a model is at telling the difference between the two classes, like separating spam from not spam. And here's a fun fact. This whole concept actually came out of World War II, where it was used to analyze radar signals to tell the difference between an enemy plane and just random noise. Pretty neat, right? Today, we use it to see how well our AI can tell the good stuff from the bad.
And the best part is, it's really easy to understand. A score of 0.5 means your model is basically just guessing, no better than a coin flip. Anything between 0.8 and 0.9 is considered excellent, and if you get above 0.9, your model is outstanding. It's just a fantastic, at-a-glance way to compare how powerful different models are.
Okay, so we have covered a lot of ground here. We've got accuracy, precision, recall, F1, AUC-ROC. So how do you pull this all together and make a decision? Well, the key, the absolute most important thing, is to connect the metric you choose directly to your business goal.
And this is basically your cheat sheet. This is the big takeaway. If you just need a quick 30,000-foot view, sure, look at accuracy. But just be careful. If the absolute worst thing that could happen is a false alarm, then you need to prioritize precision. If you absolutely positively cannot afford to miss a single positive case, then your focus has to be on recall. And if you need that balanced view or you're trying to compare different models, F1 and AUC-ROC are going to be your best friends.
And that really leaves us with one last vital question. This is the question that should start every single conversation you have about how well your AI is performing. For your business, for your project, what would do more damage, a false alarm or a case that you miss completely? Because the answer to that question will tell you exactly which one of these metrics you should care about the most.